Have you ever pondered over the strange and unexplained phenomena in the universe? What if two particles, separated by vast distances, could instantly communicate with each other? Welcome to the curious world of quantum entanglement. This world, my friends, is not as it seems. It's far more peculiar, far more enthralling than we could ever imagine. It's a world that plays by its own rules, where reality as we know it takes a back seat. This is the realm of quantum entanglement. Quantum entanglement, a term that sounds as though it belongs in a science fiction novel, is a real and fascinating phenomenon. At its core, it's the intimate connection between particles, a connection so profound that it persists no matter how far apart the particles may be. Imagine, if you will, a pair of particles that are entangled. This means they're linked in such a way that the state of one particle instantly influences the state of the other, even if they're galaxies apart. If one particle twirls to the right, its partner twirls to the left, and vice versa, all in the blink of an eye. But how is this possible? How can something happening here have an immediate effect somewhere else, especially when somewhere else is light years away? It defies our everyday logic, doesn't it? It's like magic without the wand. But this isn't magic. It's quantum mechanics. This strange connection, this quantum entanglement, poses a challenge to our understanding of the physical world. It tells us that the universe at its most fundamental level may not operate on the same principles we're accustomed to in our macroscopic world. As Einstein once stated, it's spooky action at a distance, but how does it actually work? Stay tuned to find out. Quantum entanglement might seem like a concept straight out of a sci-fi novel, but it's very much a part of our reality. This phenomenon, a cornerstone of quantum mechanics, is as fascinating as it is puzzling. So what is quantum entanglement? Let's break it down. Picture a pair of gloves. One is always a left glove and the other is always a right. Now imagine if you mixed them up in a box, reached in without looking, and pulled one out. The moment you look at it and see it's the left glove, you know immediately that the other is the right glove, no matter how far away it is. Quantum entanglement is similar, but with particles. When two particles become entangled, their states, like spin, momentum, or polarization, become linked. If you measure the state of one particle, you instantly know the state of the other, no matter the distance between them. It's as if the universe has a hidden set of quantum gloves that ensures these particles always match up. But here's the real mind-bender. Before you measure, these particles exist in a superposition of states. That means they could be in any possible state. It's only when you measure one particle that both their states become defined. This is what the famous physicist Erwin Schrödinger described with his thought experiment of Schrödinger's cat, where a cat in a box could be both alive and dead until observed. Now you might be thinking, doesn't this violate the speed of light? How can one particle know what the other is doing instantaneously? This is what troubled Einstein, who called it spooky action at a distance. But experiments have confirmed this phenomenon again and again. It seems that in the quantum world, information can travel faster than light, or perhaps outside of time and space as we understand them. This isn't just theoretical. Quantum entanglement has practical applications too. It's being used in quantum computing to create bits that can be both 0 and 1 at the same time, massively increasing computing power. It's also being explored in quantum cryptography, promising unbreakable codes because any attempt to eavesdrop would change the state of the particles and reveal the intrusion. The world of quantum entanglement is full of paradoxes and mysteries. It challenges our understanding of reality and forces us to think outside the box, or perhaps inside the quantum box. Now imagine if we could manipulate this entanglement. What possibilities could that open up? Could we teleport information instantaneously across vast distances? Could we create supercomputers that solve problems in seconds that would take current computers millions of years? Could we even entangle larger objects, or ourselves? These are the questions that scientists are grappling with today as they delve deeper into the quantum world. If quantum entanglement is the mystery, quantum flux is the key that unlocks it. Let's take a moment to dive into the fascinating world of quantum flux. It's a concept shrouded in quantum mystique, yet it's integral to our understanding of quantum mechanics. But what exactly is quantum flux? Simply put, quantum flux is the measure of change in a quantum field over time and space. Now, if that sounds a bit complex, let's break it down with a simple analogy. Imagine you're standing on a beach watching the waves roll in. The rise and fall of the water, the ebb and flow of the tide, represents the changes in the quantum field over time and space. That's quantum flux. It's like the ocean's tide, but on a subatomic level. But why is this important? Well, understanding quantum flux allows us to peek behind the curtain of the quantum world. It helps us grasp how quantum particles interact, how they change, and how they influence each other. This understanding is crucial to manipulating quantum entanglement, a phenomenon that could revolutionize everything from computing to communication. Just as a flux capacitor was the key to time travel in the movie Back to the Future, quantum flux could be the key to unlocking the future of technology. It's the flux capacitor of our reality, the component that might just take us to the next level of human evolution. However, like any key, it must be used correctly. We're still in the early stages of understanding quantum flux and its potential implications. The quantum world is a realm of infinite possibilities, but it's also a place of great uncertainty. It's like trying to predict the exact pattern of waves on an ocean, a daunting task, but not an impossible one. That's the beauty of quantum mechanics. It's a field that continues to challenge our understanding of the universe, pushing the boundaries of what we thought was possible. And quantum flux is right at the heart of this thrilling scientific frontier. Understanding quantum flux is a step towards unraveling the mysteries of quantum mechanics. But how do we get to see this quantum magic in action? The answer lies in cooling ions, light, and magnetic fields. Ever wondered how we can manipulate the seemingly untouchable quantum world? Well, the secret is in the cooling. Cooling ions in particular to almost absolute zero. That's colder than the vast emptiness of outer space. At these frigid temperatures, we can start to observe and manipulate quantum entanglement. Imagine a bustling city street full of noise, movement, and chaos. That's what it's like inside an atom at room temperature. But as we cool it down, the city quiets, the movement slows, and we can begin to pick out individual conversations, or in this case, quantum states. Now the question is, why do we need to cool these ions to such extreme temperatures? Well, the hustle and bustle of thermal energy can drown out the delicate quantum states. By cooling the ions, we reduce this energy, allowing us to observe and manipulate quantum phenomena that would otherwise be lost in the noise. But cooling ions is just part of the story. We also use light and magnetic fields to interact with these ions. Light, especially laser light, is an excellent tool for manipulating atoms. By carefully tuning the frequency of the light, we can interact with specific energy levels within an atom, allowing us to control its quantum state. Magnetic fields also play a crucial role. They can be used to trap ions, holding them in place so we can interact with them. By adjusting the strength of the magnetic field, we can change the energy levels of the ions, enabling us to control their quantum states. Over the years, a number of experiments have been conducted using these techniques. One of the most famous is the work of David Wineland and Serge Haroche, who shared the Nobel Prize in Physics in 2012 for their groundbreaking work in quantum manipulation. Their experiments provided some of the most convincing evidence yet of quantum entanglement, proving that this spooky action at a distance is indeed a fundamental aspect of our universe. These experiments are not just about understanding the quantum world for the sake of knowledge. They have practical implications too. Quantum computing, for instance, relies on our ability to manipulate quantum states. These computers could potentially solve problems that are currently beyond the reach of our most powerful supercomputers. So when we talk about cooling ions, using light and manipulating magnetic fields, we're not just talking about scientific curiosity. We're talking about the potential to revolutionize technology, to solve complex problems, and to advance our understanding of the universe. When we manipulate these elements, we're manipulating the very fabric of reality. So, you may wonder, what does all this quantum talk have to do with us humans? You're not alone in that thought, and it's a question that has been puzzling scientists for quite some time. But believe it or not, this quantum phenomena may have a significant impact on the evolution of humanity. Let's start by thinking about communication. In our current digital age, we send millions of bits of information across the globe in the blink of an eye. But even this speed could pale in comparison to what quantum entanglement might offer. Imagine being able to exchange information instantaneously, no matter the distance. This faster-than-light communication, coined as quantum communication, could revolutionize how we connect and interact, breaking down geographical barriers like never before. Now let's move on to computing. Traditional computers use bits, which can be either a 0 or a 1, but quantum computers use quantum bits or qubits, which can be both 0 and 1 at the same time, thanks to a property called superposition. This means quantum computers could potentially process vast amounts of data at speeds unattainable by today's standards. Quantum entanglement, the ability of qubits to be interconnected, plays a crucial role in this. It could lead to a new era of computing power, enabling us to solve complex problems and process information in ways we can only dream of today. But the possibilities don't stop there. The field of medicine could also see a radical transformation. Quantum entanglement could open new avenues for drug discovery and disease detection. For example, it could enable the creation of highly sensitive imaging tools that can detect minute changes in the body at the cellular or even molecular level. This could lead to earlier detection of diseases and more effective treatments. Moreover, some scientists hypothesize that quantum phenomena might already play a role in biological systems. For instance, there's a theory that quantum entanglement might be involved in DNA mutation and evolution. If proven true, this could give us a whole new understanding of how life evolves and adapts, potentially leading to breakthroughs in genetic research and bioengineering. In essence, the implications of quantum entanglement and flux on human evolution could be monumental, from transforming how we communicate and compute to revolutionizing medicine and potentially even influencing biological evolution. It's a prospect that's both thrilling and daunting. We're at the precipice of a new era, one where the line between science fiction and reality gets blurry. Yet as we venture deeper into the quantum realm, we must also be mindful of the ethical implications and challenges that these advancements could bring. We're stepping into uncharted territory, and with great power comes great responsibility. From faster-than-light communication to quantum computing, the implications are as exciting as they are mind-boggling. We're on the cusp of a quantum leap in human evolution, and it's a journey that promises to be nothing short of extraordinary. Quantum mechanics, with its entanglement and flux, is a complex field, but it's also one that's incredibly fascinating. So let's take a moment to reflect on this whirlwind journey we've been on. We began by diving into the mysteries of quantum entanglement, a phenomenon so bizarre, it left even Einstein scratching his head. We discovered how particles, no matter how far apart they are, can be interconnected in such a way that the state of one instantaneously affects the state of the other. It's as if they are two sides of the same coin, forever linked, regardless of the distance between them. From there, we ventured into the realm of quantum flux, a concept that's just as mind-boggling. We learned it's not just a cool term, but it's essentially the heartbeat of our reality. It's the fluctuation of energy at the quantum level, a dance of particles popping in and out of existence, shaping the fabric of the universe as we know it. Then we explored how we can manipulate these quantum phenomena. By cooling ions, light, and magnetic fields to almost absolute zero, we're able to slow down the particles' vibrations and have a clearer view of their quantum behavior. This gives us the ability to control quantum entanglement and flux, opening the door to new possibilities in quantum computing and communication. Finally, we speculated on the potential impact of quantum mechanics on human evolution. Could understanding the quantum world lead to a new stage in our evolution? Could it offer us new ways to interact with the universe, or even uncover hidden abilities within ourselves? Only time will tell. So next time you gaze up at the stars, remember, there's a world of quantum wonders waiting to be discovered. Until next time, keep asking questions and exploring the universe.